Hey, I'm Doug Draper with Acme Distribution and the Denver Transportation Club, and I'm pleased to present our series Supply Chain and Logistics, the Storytellers. Series is brought to you by Cap Logistics. Cap Logistics are experts offering you customized transportation solutions for all of your needs. So please visit Cap Logistics today. I'm excited about our topic, and we have some wonderful guests. So we're going to talk about 3D printing and logistics and how the technology has been a disruptor and transforming the supply chain. So we have a couple of phenomenal guests with us today. Adam Papilion with H2 Manufacturing.
Yep, thank you.
Thanks for joining us.
Thanks for having me.
And Heidi Hostetter with Foutson.
That's right.
All righty.
Thanks for having us, Doug.
Yeah, thanks. So before we jump into the details of the topic, we just like to learn a bit about our guests. So Adam, we'll start with you. Maybe tell us a little bit about yourself.
Yeah. So I am the Director of Operations for H2 Manufacturing Solutions. Work very closely with Heidi. She's the CEO of that company. We do a lot of different projects in the state for manufacturers, mainly in the consulting space. But we like to say we'll go in and help any manufacturer with any problem to, make their day-to-day life a little better.
Yeah, excellent. All right, up to you, Heidi. Tell us about yourself.
Oh my gosh, Jill of all trades, not master of one.
Yeah,
that's the first thing you need to know.
Yeah, good deal.
For the last 18 years, I've run a high-precision manufacturing machine shop here in Colorado called Foutson. Our emphasis and focus has been on aerospace and defense. I would say that we joke around and call ourselves the iPhone of our industry because we tend to get into disruptive technologies or, we're early adopters, which has led us into the very thing we're going to talk about today, which is the 3D metal printing.
Excellent.
Yep.
Good deal.
And then as a result of that came the characterization lab at Colorado School of Mines, which is now known as ADAPT.
Okay.
Yep.
Excellent. Well, I know you're fighting a little bit of a cold here, so I may defer to Adam on some of the comments. You can give me a thumbs up or thumbs down, but
great.
You're doing awesome. So I like to keep things super simple when we start off. So let's just take a step back and explain what 3D printing is to our audience and kind of the different mediums that are used when 3D printing.
Sure. Yeah. So 3D printing is basically exactly what it sounds like. You're printing things in layers, and as it stacks up in Z, that's how you're going to create your part. In the metal world, it's mainly a powder bed 3D printing. So the metal is a powder-based material. It goes into the machine. Lasers will melt pools of the metal in specific areas, and then it'll layer another thing of powder over that layer and stack it up in the Z again.
Okay.
So it's basically like welding in layers.
Gotcha. And so the powder actually, is it heat that creates the different layers? How does it go from a powder to something that's tangible?
It's a laser.
Gotcha. Cool. All right. So what is the history behind 3D printing? I know it's kind of this is an awesome technology, but I'm sure it had some origins. So talk to us a little bit about that.
Yeah. So it was back in the 80s. It was invented as a polymer printer, and the technology really didn't take off for about another 20 years. And then that's when we kind of saw some advancements in the technology, and polymer printers became much more mainstream. And now you can get polymer printers for you could get a little desk one for like $150, $200 that you can prototype things at your house with.
Right. So
they're making it very feasible for even the end user to get them. And then on top of that, it's they're having open source stuff for a lot of the designs too. There's a big movement with prosthetics where they're releasing the designs out to the community and allowing everybody to utilize that if they wanted to print their own or just making it more access to the public. And that's the big thing is the data. The machines are capable of quite a lot of very intricate parts, but it's the data on the machine settings and how you print those things, the orientation of the part, what are your critical features. It's those things that really make the print come out as a better part.
Right. Yeah. So when you say data, is that just, it's open source? So if I want to make a prosthetic, is it a file that I access, or tell me about the process to take the data, whatever that is, and plug it into my $150 desktop printer? I know metal's a little bit different, but let's start with the polymers. Like, walk through that process.
So the data, I mean, it would come in like a CAD or like an STL or step file, and basically the printer software will break it down into layers.
Slice file.
It's a slice file, yeah. And then in those layers, each layer the printer will print, and eventually, you know, at the end of it, you'll have your part.
Gotcha. So talk a little bit about the technologies that it's being applied. I mean, just now we talked about prosthetics and other things of that nature. What are some different technologies and type of things that are really embracing the 3D? Yep.
Well, I'm going to take this from the metal stance because I'm a gearhead, so I don't care about any of that polymer stuff. I mean, I do, but I don't know anything about it.
Yeah,
but
go for it.
You know, Colorado becoming #1 per capita, right, in aerospace and defense. This printing of metal was made for this industry because you're lightweighting parts that, I mean, cost you $10,000 a pound on the payload, right? That's our money.
Yeah.
That's constituent dollars.
Right.
At work. So, you know, you look at this technology, for example, you look what GE did with it. I'm sure you know about the GE fuel nozzle, Doug?
I do not. Why don't you tell us more about it?
But in the aeronautics world, they took it by storm in 2012 because they took a fuel nozzle that was basically 19 different part numbers that needed assembled together, brazed, welded, the whole shebang, and they now print one. So they've eliminated all those processes. Yeah. They've dealt with their workforce gap because we all know there's a huge workforce gap in our nation.
Right.
You know, they've lightweighted the part by, was it 30%?
I think it was like 25 or 30%.
You know, they increased the efficiencies by pretty much that same number.
Right.
I mean, you start to talk about stats like that, you can't not look at this as a solution, right?
Yeah, for sure. So when you say it was lightweighted, okay, so for me it's like, all right, we got 19 parts, I get that. How is the durability? So this piece is now 20% lighter or 20 times lighter than it was before, but how durable is it?
They say it's 19 times more durable, and they've tested it, and it's in every LEAP engine that we know of.
LEAP engine?
Yeah.
What is that?
I think they're Boeing, and they're on like the 747s. I mean, you literally flying on planes right now without even knowing that you're on a plane with 3D parts on it.
Interesting. How do they mass produce that? Right. So you got an airplane, and there's this, the Henry Ford production line. We just talked about polymers, which we're focused more on the metal now, but it takes a while, right, to print this this part. So
wait a minute, you mean actual time?
Yeah, the actual time to make the part. Part? Yeah.
No.
No?
Oh God, no. No, all the time is invested up front in the R&D, the material characterization. Once you figure that out, and of course the equipment, and I'm not going to go down this huge rabbit hole when we have a limited amount of time.
Sure.
It could get pretty technical, but you're taking 19 different part numbers, let's say, that were traditionally machined. If you called a machine shop lately to hear what their capacity is, the good ones that do flight, aerospace, and defense, 8 to 12 weeks just to get on the machine.
Gotcha.
Then whatever to produce the parts. You're half a year out. Now you got to send it out for welding. That's probably another 1 to 2 weeks. Brazing, who knows what, right? Before you know it, you're at an 8-month lead time.
Gotcha.
Those parts come back. Now, guess what? Hopefully you have qualified staff, Doug, to assemble those parts. Have you tried to get assemblers lately? Pretty tough to do, right?
Yeah, yeah. So, well, that makes sense. So the physical making of the part is like, really not the game changer. It's the process to get it to...
well, it's the physical making and all of the, what we called secondary ops.
Right.
But you're going to print this part. You could take a part that might take you 12 weeks to machine.
Mm-hmm.
You get printed in 30 hours.
Mm-hmm.
That's crazy.
Yeah, I mean, we consider it the next industrial revolution, you know, because it's already proving to do things that you can't traditionally do with manufacturing techniques. And, you know, the GE Leap engine's a great story. And any place where you want to save weight and not compromise strength is a good application of the metal printing.
Right.
Well, let's talk about the space station.
Mm-hmm.
What if you don't even want to put a bar, send it up for $10,000 a pound? What if you just send the digital file up to the space station and they print it?
Yeah.
That's going on right now.
Yeah, they have one in the International Space Station, a 3D printer, and they're actually advancing the technology even more with that because there's no gravity in space. Mm-hmm. And one of the 3D printing's biggest enemies is gravity, because if you think about printing something that goes out horizontally or is, you know, greater than 45 degrees, it has nothing to support what you're printing on, so it will sag and it'll drip. So in the space station, they're able to print it in zero gravity, which is making their designs more intricate even.
Mm-hmm. That's interesting. So on the printing up in space, in my mind, it's small parts that are piecing together. Do you see an application where it's building massive structures, and maybe we're already at that level?
No, I don't see that yet. I don't see that for a while because we're still trying to work out some of the characteristics. You've got to, I mean, the gravity works in your favor, but you have to look at temperature, like coefficiencies. There's all kinds of things that we struggle to define on a part the size of your hand,
right?
Much less the size of this table,
right?
So kind of, you know, walk before you run.
Yep.
That's only my opinion. That does, you know, you might get academics and other technologists that would disagree, but I would say you're a decade out from that still.
Right. Okay.
But we should all be working toward it.
Right. Mm-hmm. Yeah, that was my question. Next question was the time frame. So you think it's a decade out or something of that nature?
On the metal side, for sure.
Yeah.
For sure. Mm-hmm. No question.
Gotcha. So let's talk about the supply chain. When I think of 3D printing, you know, there's companies where a system goes down, a manufacturing in, say, a remote area, mining, oil and gas, and here's this small little widget. Let's call it a flux capacitor for visual perspectives, right? So you have this in a specific location, and you're spending hundreds or thousands of dollars to get it to a point very quickly. Disruption in the supply chain, you have a 3D printer up there, you don't have to worry about that. Is that kind of how you're seeing the
It's
impact?
just the digital exchange. And I could tell you, after running a machine shop for the last 18 years,
mm-hmm.
the setup involved with this technology is glaringly more simple.
Mm-hmm. So what do you mean in setup? What do you mean, like just getting the
actual physical part set up on the subplate or on the plate, the build plate, and ready to go? You're basically dealing with support structures where you're going to support the part, where you're going to get the best build, this sort of thing. But I have guys in the traditional world, which we call subtractive, right? Where they could be setting up for a month, programming, setup, figuring out how to approach a part, right? You don't have that in this digital world. So what you speak of, Doug, is really real. I mean, if the file's clean, you've got the support structures figured out, it's a file transfer, you could print overnight.
Yeah.
Nobody even needs to stand there and watch it.
Really? That's interesting. So what other type of industries? We talked about aerospace and we talked about the space station. So what other type of applications are out there in the metal fabrication?
It's I mean, just 3D printing in general is hitting pretty much every industry across the board. You know, they're doing jewelry, they're doing clothing, fashion.
Even food.
They're doing food. They're doing houses out of cement printers. They're printing, you know, these huge, big printer heads are printing cement right out of it and building houses in one day a house. You know, so really crazy stuff.
Huh.
It's hitting the medical industry really, really big.
Right.
They're printing metal joints that are custom to people's anatomy. And then on top of that, they're able to be so intricate with the printing, they can print microscopic holes so your bone can grow into it quicker and adapt to that implant much faster. So there was a story here actually that was in Littleton, where this guy had a pelvic bone cancer, and they actually removed all of the cancerous bone and replaced it with a 3D metal part. And within 7 weeks, the guy was already on crutches walking upstairs, and that's just kind of unheard of in the medical world.
Did they just lattice so that it could all grow through the lattice?
Yeah, they did.
Oh, cool.
Wow, and that happened.
That is, yeah, that's
Is
a pretty...
that 3D print systems?
I don't know where they got the part from. I saw it on the news, and the guy lives in Littleton, and it was a, you know, kind of just in our backyard story, and I thought it was really cool.
Yeah, that's amazing. You mentioned food. So talk about that. Is it just like baking?
I don't know anything about it because I wouldn't eat it. I am not eating anything that comes out of a printer.
Yeah.
I'm an early adopter.
Yeah.
But not with my food.
No. Would you eat it?
I mean, it looks. I kind of did some research on it. It's basically like a decorative printing. Like they'll be printing like chocolates on cakes or designs of different, I guess, decorative.
Yeah. So the
Sweets.
answer is yes.
So the answer is yes. So the answer is yes.
You had me at chocolate. I think we're set. So.
Right.
Cool. So medical, aerospace, we've talked about all these amazing things it can bring to the table. What challenges do you see, right? They can't all be lollipops and sunshine out there. There has to be some challenges that we're seeing with the production. Can you talk a little bit about those?
Yeah. I mean, one, let's just say it really, especially in the metal world, isn't for everybody. It's just not. You really have to get clear what you're trying to solve, the problem you're trying to solve, less about commodity, more about a problem. And, you know, additionally, I think that as much as our industry sees that supply chain has issues, we have workforce gaps, really asking people to be early adopters and truly practice what they preach. Yeah. It's a big ask. People want a lot of reassurance to dip their toes into this new technology.
What's going to take it, what's the tipping point to take it from early adopters, like this is great, some of the things we've talked about now, to kind of be mainstream where everybody would feel comfortable to 3D print a bone that's going to get grafted in your forearm? What do you think's the tipping point for that to...
Well, I'd be curious Adam's answer, but I could tell you that I think we're there. I don't know specific to the medical side. However, I could tell you that, you know, running a business at this day and age has gotten more and more trying. And so we tend to look toward innovation and innovative, I guess, pivots to help us grow our business. When we have human capital issues, the things that we're facing. So I think we're there. I think if you're not there yet, you have no desire to be here in the next few years. That's just the truth. And I think in the next 12 months, we're going to see a lot of people kind of have their hand forced to start to look at these things.
And forced because the resources are going to be so lean with
natural resources, human capital, you know, you name it. Yeah. Aluminum right now, 75, 4 inches and thicker, certain sizes is 32 weeks out. People can't wait that long to get to market. Yeah.
What are some of your thoughts on some challenges that
are
coming down?
I totally agree with Heidi, and I mean at this point though, I don't think it's going to be replacing technologies. You know, it's very complementary to those. Like you wouldn't print sheet metal, for instance, because it's just so cheap to produce it how we've already, you know, done it traditionally.
Sure.
I think the real benefit is going to be in what you can do with the technology that you can't do with the traditional methods of machining or anything like that. So, and on top of that, when some of the technology does advance and drive costs down, that'll be a big innovation that will push industry to move towards it more. I mean, just kind of imagine even if you could print a shoe and you're a shoe factory, if you didn't have to manage any inventory because everything was print to order. You know, think of what that would do to reduce a company's overhead if they could do that. I mean, we were up at Aleph Objects last week actually touring their facility, and they have 150 printers that are printing 3D printers.
Oh, really?
Yes, they are printing the parts.
60% of the printer itself is made with their printers.
Oh my gosh, that's crazy. Yeah, there's, you know, I've always wondered. So you go into a shoe store, right? Like you said, inventory. There's how many different SKUs, size runs, colors, styles. You show up and you just pick it off of a wall and you say, measure my foot, and I'll be back in 2 hours, an hour, 10 minutes, whatever it is.
They're printing shoes now.
They're already printing.
Who is it, Reebok?
I think so.
I hope it's not Nike. Oh my God, did you see that? Duke?
No, I didn't.
No, what are you saying?
Duke lost their most valuable player during the Final Four or something. Not the Final Four, it's some game, and they lost because his shoe blew apart.
I know you're talking about.
Oh, wow.
He did the pivot.
Hopefully it's not Nike.
Yeah, I hope it wasn't printed. Nike.
Zion Williamson from Duke. I know what you're talking about now. So.
Remember?
I do. It's just a couple of weeks ago for sure.
Amazing.
Yeah.
Yeah, but I do think that's the direction that things are going to go. And you have to find your cost savings. That's why it's great for aerospace right now, because the cost savings is in the weight and in the number of pieces you have and the assembly and the workforce. But, you know, when you go into mass production, sometimes, you know, metal casting and molds is a little bit cheaper if you're going to get 10,000 parts. That's why the medical industry is doing so good with it, because they want to have custom implants for people. So every piece is different than the last one. Whereas if we were going to mass produce 10,000 pieces, it might be cheaper to go into a casting route.
But you'd want to print the mold.
But you want to print the mold, exactly.
Right, because that's going to save you 6 months and $200,000.
And you want to print the prototypes, because if you get the mold without prototyping it and the mold isn't the right mold and isn't the right part, you just wasted $100,000 or even more.
Yeah. I think you just answered the next question I was going to ask, which is, how do you make sure you're printing something in the field? How do you make sure it works, it fits right, and it's all about the mold? Yeah,
well, I mean, this technology is just made for prototyping. I mean, form, fit, pseudo functionality. That's what this is for, because you could do it quick.
Yep.
You could do several parts. You could do a ton of different parts on one build plate to create an entire assembly.
Yeah. With
a machine, it's one type of part at a time.
Yeah. Yeah, I can see that for sure. All right, so this is the fun part of the show. Let's talk about 5-10 years down the road, right? Give us, paint some visuals of the things that we're going to see in our daily life that are going to benefit from 3D printing.
Oh. Honestly, I think that medical stuff, like what your dad's into, Adam.
Yeah.
I think it'll be like a sushi order. I'm 5'5", 130 pounds. None of that's true. I'm way thinner than that even.
Yeah.
But you know,
taller.
You're gonna really check off your specs, and they're gonna produce whatever, your hip replacement, your knee joint.
Yeah, I do think that's going to be really innovative, and that'll be when the cost gets down to where it's affordable for hospitals to, you know, have a 3D scanner on site that they could scan somebody's bone, you know, digitally make the plate for them, print it at the hospital, and then the next day the person could go into surgery.
Yeah.
You know, so I think that would be a future I'd like to see with it.
Yeah. Yeah, from a logistics perspective, you always wonder all these parts depots, you know, that are spread out all over the country. And I have, you know, 5,000 of this widget in 100 different locations across the country because I need it at that hospital just in time. But the prototyping and be able to make it on the spot is pretty impactful for sure. So, well, I'll tell you what, it's been a quick discussion, but it's been very informative and impactful. So I want to thank both of you for joining us today.
Yeah, well, thank you for having us, Doug.
Absolutely. And I want to thank our audience for joining us today on the Connect and Collaborate Network, featuring Supply Chain Logistics, the Storytellers. Of course, it's brought to you by Cap Logistics. So thanks again, and have a great day.